Hey guys, welcome to lesson 2, and today we are going to start off with 2 new formulas that are just going to pull from what we talked about yesterday. So this is a compound interest formula that is used quite a bit, and this is the present day value formula. So I'm going to show you how each of these are kind of played out. It's really the same formula, just kind of altered for what we want. So just kind of keep all of this in mind. So principal is always what you stick in. Rate, that's your interest rate. Time is always in years. So if they give you like 6 months, you need to say like 0.5. So just kind of keep that in mind. So notice the P and the A are transferred. Oh, and so A is like what you pull out at the end. So this is like the P is before and the A is after. Okay, so what I want you to do is look in your books on page 315. We're going to look at problem number 83 and 80. Okay, so problem 83 talks about how Melissa borrowed $40,000 at 12%. So that's our beginning amount, 40,000. 12% is our interest rate, and she made no payments for 3 years. How much did she owe the bank at the end of 3 years? Okay, so we are going to use this compound interest formula. So she borrowed, so this is at the beginning, she borrowed 40,000 at 12% interest. So we're going to turn that into a decimal for 3 years. And so go ahead and type that in your calculator. And you should get $56,197.12. So think about this, guys. When you go to borrow money for a house or something, like in just 3 years, and I know 12% is kind of high for home loans right now, but in 3 years, like she had to pay $16,000 more. So think about like a home loan. Usually they're like 20-year loans, and so you're paying a lot of interest on those loans. Okay, so let's look at problem 85. Okay, so Mr. Watkins wants to have $10,000. So this is his goal, $10,000. How much should he deposit in an account with paying 7% interest compounded annually to have $10,000 in 18 years? So he wants to stick money into an account, and his goal is $10,000. So that is his end result. So we're going to use this bottom formula. %7 interest. And so it's negative because we're going like backwards in time, if you want to think about it like that. So make sure that you can type that into your calculator. Your amount should be $2,958.64. This is something we did for our kids when they were little. We wanted a set amount. We wanted $15,000 per kid in an account when they were ready for college. And so we kind of worked through this and did the same thing. Okay, so this part is nothing new. We're just going to review polynomials. So the largest power of x is called the degree of the polynomial. So a lot of times, like, we need the degree to kind of classify the polynomial. So if I have like 5x to the third plus 6x to the fifth, the degree of the polynomial would be 5. The coefficient of the term with the degree is called the leading coefficient. So just because this comes first, this isn't like in proper order. This is my leading coefficient. So my leading coefficient is 6. So we use that a lot in helping us figure out things. Okay, so you've had these before. They're classified by degrees and number of terms. I'm just going to go through and fill this out really quickly. Okay, so again, this is just a review. So what we're going to do is I want you to classify this polynomial. So state the degree and leading coefficient of the polynomial, and then I want you to evaluate it. So everywhere you see an x, I want you to plug in -1. So you have 3 things to do. So this is what kind of comes through my mind. These are both even, so my 1 is going to be positive. So I have 3 plus 7. This is an odd, so it's going to be negative. So I have -2 times -1 is a +2. And so I'm just going to add these together. So 10 plus 6 is 16. Okay, so we have 3 things that we're going to do here. We're going to add, subtract, and multiply. When you're multiplying, some of you guys like to do the box method. That's totally okay. What I do is I take this and distribute it to everything. And then take this and distribute it to everything. And then finally take the 1 and distribute it to everything. So that's my game plan there. So I'll show my work on all of this. Make sure when you are subtracting all of these. So I like to change the sign on that. So I'll show you that as well. Okay, if you look, these are